This is the introduction to trigonometry. These formulas start on page 22, the bottom right hand side of page 22 on the reference handbook. Starting off, the trig functions are basically defined using a right triangle. So drawing that out, we have 90 degrees. We'll call that theta. Let this be y, r, and x. So, the basic trig functions. There's a mnemonic that I like to use, and let's write them out. So for the basic trig functions, we have sine, cosine, and tangent. And that mnemonic I mentioned is Oscar had a heap of apples. So this would be opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So you can see we've got sine is opposite over hypotenuse, which is equal to y over r, and so on and so forth. So in the context of this, I think something that is really important to grasp and understand as we go forward with all of our trig identities and trig functions and trig ratios is the unit circle. And what is the unit circle? Well, let's draw it out. Wow. So the unit circle, by definition, it is 1 unit. The radius is equal to 1 in all directions. So that would give me this point would be 1, 0. This point would be 0, 1. This point would be -1, 0. And this point would be 0, -1. So, just one thing to point out. So we're used to working in regular angles, but one thing on the unit circle, is really good to grasp is radians. So what are radians? Well, let's start by looking at this. Let's say how many radians goes around? Well, start with what's the circumference of a circle? The circumference is equal to 2 pi r. So going back to a unit circle, the radius is equal to 1, so I can get rid of that. So 2 pi. So going all the way around is 2 pi, which is that complete circle is 2 pi or 360 degrees. So taking that up, if that's 2 pi, this would be half pi, this would be pi, and this would be 3/2 pi. So we can also use, once we have this drawn out, we can also use these trig functions, these ratios, to figure out additional points on the unit circle. So let's look at this angle right here. So this 90 degrees right here, if we're splitting that angle, well, let's call that 45 degrees. So let's draw this triangle. Again, it's just taking this and putting it down here, because what I want to do is I want to be able to find this point right here. I want to be able to define this angle, which I said is 45 degrees, but I want to define that in terms of radians, and I also want to be able to find what are these 2 points? What is this x and y coordinate? And I think we'll be able to see that by going back to our sine function. We know that it's the opposite over the hypotenuse. And we know that the hypotenuse is 1, so it's going to simplify things quite a bit, and we'll be able to pick out and find a lot of points along the circle. So going back, we've got, this is a 45-degree angle right here. This is 90 degrees, and we know that R is equal to 1. So let's start with this 45-degree angle first. Let's convert it to a radian. So we got 45 degrees, and we want to convert to radians. So what do we know? We know that 180 degrees, if I take this pen and sweep it all the way around from here to here, I know that is 180 degrees. Well, how many radians is it? It's pi radians. So doing that math, this will convert out to 1/4 pi. So that I know that this angle right here is pi over 4. Now let's find what these x and y coordinates are. So going back, let's look at, again, this would be my y and this would be my x coordinate. So x here and y here. So let's get our y first. So let's take the sine of this 45 degrees is equal to y, which is my opposite, over my hypotenuse, which is the radius, which is 1 because it's a unit circle. So the sine of 45 degrees, let's pull a calculator out. And let's go sine 45 is equal to the square root of 2 over 2. Now let's find the x. So we can go the cosine of 45 degrees is equal to x over 1, or adjacent over 1. So let's plug this in. Let's go cosine 45 degrees is equal to the square, it's the same thing, the square root of 2 over 2, which kind of makes sense here. So let's write this in, give myself a little bit more room. So we've got, that is the square root of 2 over 2, and the square root of 2 over 2. So moving on, we've looked at 45 degrees. Well, what are some of the other basic triangle angles that we should probably know or be able to find very quickly? Well, what we've looked at is 30, 60, 90 triangles, our standard right triangle. So let's take just a little bit more room here. So let's look at let's look at 60 degrees on the unit circle. So we'll draw a mini unit circle here for now. So we want to go 60 degrees. So we want to find the point here, knowing that is 60 degrees. So let's draw this triangle just a little bit larger. 60 degrees. We want that point. And I want to be able to tell you what this point is. And then I want to give you the x and y coordinates. So again, let's convert our 60 degrees over to radians. So we've got 60 degrees. I know that they are 180 degrees in pi radians. So if I calculate this out, I'm going to say that is equal to 1/3 pi. So let's keep going forward on this, and let's say that I want to find my x and my y, and again my r is equal, my radius is equal to 1 on the unit circle. So sine of that 60 degrees is equal to y, which is equal to the sine of 60 degrees, which is equal to the square root of 3 over 2. And then let's look at our x coordinate. Is cosine of 60 is equal to x, which is equal to cosine 60, which is equal to 1/2. So I know this is 1/2, and this is square root of 3 over 2. So how about the other triangle, 30 degrees, which is going to come maybe out like this. So let's draw that triangle. And let's call that 30 degrees. Again, our radius is equal to 1. We're still on that unit circle. It actually comes out like that, but this will be x, or that will be x, and that will be y. So let's convert our 30 degrees. There are 180 degrees in pi radians. So that comes out to 1/6 pi, and the sine of 30 degrees is equal to 1/2, which is equal to y. The cosine of 30 degrees is equal to the square root of 3 over 2, which is equal to our x. So we know that this angle is 30 degrees, but it is also equal to 1/6 pi, which is equal to, or not equal to, but rather this point on the unit circle is the square root of 3 over 2 and 1/2. And again, that is pi over 6. So that's just some of the basic angles that are usually that we'll usually see on the unit circle. So let's write that all out on one unit circle so we can see it all in one spot. So let's draw one very large unit circle. Again, this is 2 pi, half pi, pi, 3/2 pi, and let's start with our angles we did here. We did 45 degrees, we did 30 degrees, and we did 60 degrees. So what was that? That was pi over 6, pi over 4, pi over 3. And let's write our points in here. This was at 2 pi, we're at 1 and 0. Because remember, this is radius equals to 1 all the way around our unit circle. So this is at 2 pi, we're at 1, 0. At half pi, we are at 0 and 1. At pi, we are at -1 and 0. And at 3/2 pi, we are 0 and -1. Now as we use our trig and cosine functions to find these points, they are square root of 3 over 2 and 1/2, the square root of 2 over, let me write that a little bit better, the square root of 2 over 2, and the square root of 2 over 2. And at 1/3 pi, these coordinates are 1/2 and the square root of 3 over 2. And there we have the basic unit circle. So I mean, this is good to know because it's really quick, it's really fast. If I'm seeing a radius is equal to 1, it's really easy to find. If I know what the sine is, I know what my y is, and I know what my x is, and I can find that for all of these points around the circle. So anyway, I hope that helps, and on the next video, we'll continue on with the law of cosines.